Good morning, everybody. Today we're going to be talking about function tables. So check your Haiku page. It'll tell you what page in your notebook to put this information. But I want you to go ahead and pause the video and write down your 2 learning targets, which say I can write an equation for data in a table, and I can complete a table based on an equation. And then the title of today's page, which is function tables. Now that you've written down this information, you're going to need a copy of 2 things. You need this copy, and you also need this long sheet. When you get this long sheet, you're going to use all 3 of these. So you're just going to see that I'm going to go ahead and cut apart these 3. And throughout the video, we're going to be gluing these down. So don't lose them. Keep up with them. Today we're going to be talking about function tables. So before we start, we have to make sure that we know what a function is. And this is a new word for you, so you're going to see that I'm going to highlight this word. This is a function. A function is a set of input and output values that follow a math rule. So I'll let you write that down. A set of input and output values that follow a math rule. And really it's just like a math machine that you put numbers into and you get numbers out of. Your input is the value that you put into the function. And the output is the value you get as a result of using that math rule. So we've already kind of talked about input and output tables when we talked about ratio tables. And really it's just a matter of looking for patterns in numbers. So for example, if my function is x plus 2 and you put in, or your input value is a 3, that means 3 plus 2 gives you 5, and so your output value is 5. Now we're going to talk about it in terms of the tables that we have, because we're working on function tables. So I'd like you to take this copy. So find this function table, and we're going to glue it right here in our notebook. Now, generally, your input will always be your x value, and your output will always be your y value. So really what you have to do is you have to see, how can I get from this x to this y? So to get from 1 to 2, you have a couple of options. You could either add 1, or you could multiply by 2. And then we look at 3 to 6. How can I get from 3 to 6? Well, I could either add 3, or 3 times 2 would give me a 6. So what you see me doing is I'm trying to figure out what is the pattern from how you get from your x to your y. So let's look at 5. How do I get from 5 to 10? Well, I could add 5, or I could multiply by 2. So if you're following along with this video, you see that there is a pattern that develops. With all of these, we said that you could multiply by 2 to get from your x to your y. So obviously that's the pattern that we want to go with. So that means that we want to do 7 times 2, 9 times 2, and 11 times 2 to figure out what our output values are. So we're going to do 7 times 2, which is 14, 9 times 2, which is 18, and 11 times 2, which is 22. So then our job becomes, we have to write the rule. Meaning, what is the rule that we used to get from our x to our y? And what we did is we did our x times 2, and that gave us our y. Another way to write this is 2 times x equals y. So that's our function. That means any input value that I gave you, you could plug it in here and you could figure out what your output value would be. So if your input value was 100, you would do 2 times 100, and your output value, or your y value, would be 200. So now that we're finished with that one, we're going to work on the next one. And the next one looks like this. So if you'll find this function table for me, it says -1 and 5, 1 and 7, 3 and 9. So just like we did before, our job becomes trying to figure out how did we get from this number to this number. Well, if the negatives scare you, just skip that and move on to your positive. So to get from 1 to 7, we can add 6, or we can multiply by 7. How about 3 and 9? To get from 3 to 9, we can add 6, or we can multiply by 3. And eventually what you'll notice is that there are some patterns that you see developing. From 5 to 11, well, that's an adding of 6, or there's really not a clear multiplication rule there. We know that we can multiply by something to get there, but we're not going to use that value. So let's think about this. From -1 to +5, if I start at -1 and I want to get to +5, 1, 2, 3, 4, 5, 6. So it appears that the clear rule here, the rule, is that we take our x and we add 6 to it, and that gives us our y. Now we know that we can write this another way. It could be x plus 6 equals y. You know, according to our laws of equations, that we can flip those around. So let's fill in the rest of our chart. To figure out what this output value would be, we take our 7 and we add 6, because that was our function rule. So 7 plus 6 will give me 13, and 9 plus 6 will give me 15. So we completed our function table. The next function table that we're going to work with looks like this. So if you will find this function table for me. And we're going to try to figure out how we got from here to here. So again, you can think about it like if I'm at -2 and I'm trying to get to +2, that's a movement of +4. This also could be times a -1, but some of you don't know those rules, so it's kind of difficult for you to understand that. If you look at 0 and 4, you know that this is +4 because there's no multiplication relationship there. And how about 1 and 5? Well, that's either +4 or times 5, but you see that the clear pattern that happens here is that we're adding 4. So our rule, let's write our rule, is going to be x plus 4, because that's what we were doing, is equal to y. X plus 4 is equal to y. We know that that could also be written y is equal to 4 plus x, or x plus 4. There's lots of different ways that you can write that. So let's go fill in the rest of our chart. So we're going to add 4 because that's the rule. 2 plus 4 gives me 6. 3 plus 4 gives me 7, and 4 plus 4 gives me 8. So there's the finished function table for that one. Now you can also use function tables to describe real life situations. So you have this copy, and it talks about Abby's babysitting. Now we've already done this a little bit in our previous lessons whenever we tried to figure out the relationship between some values. But this says it's comparing the number of hours that Abby worked, which we're not using an X here, notice we're using an H, to the amount of money that she got, and we're using an M for money. So we're trying to figure out what's the relationship between the hours that she worked and the amount of money that she got. So if you look at 5 and 30, so think about if you worked 5 hours and you got $30 for that, could you tell me how much you made each hour? 5 hours gives you $30. So we know that that's a multiplication relationship, and that means I made $6 each hour. Let's see if that works for this one. So 6 hours times 6 would in fact give me 36. 7 hours times $6 each hour would give me 42. And 8 hours times $6 each hour would give me $48. So it appears that the rule is that for each hour I work, so H, or each hour that Abby works, we're going to multiply that by $6. That's a multiplication, not a minus. And that's going to tell me how much money she's going to make. Another way that you could write this is the amount of money that Abby's going to make depends on or is equal to $6 times every hour that she works. So it doesn't matter how many hours she works. Let's say that one week she worked 14 and a half hours. Well, all you would have to do is say 14 and a half hours times $6, and you know that she's going to make $87 for that week. So these are function tables. Basically, our job here today was to write equations based on information from a table, which is exactly what we've been doing. You're looking for a pattern in the table to see what's going on with that, the X and the Y value, or the input and the output values. And then you're also able to complete the rest of the table based on that new rule that you wrote. So you will need to reference your Haiku page to know what page this is in your notebook. Your title is Function Tables, so you can go ahead and add that to your table of contents, and then you can move on to the next page. Now on the next page in your notebook, you're going to need a copy of this sheet. You will see that on this sheet you have 4 different function tables. You're going to start by cutting all of those out and gluing them onto this empty page on the next page of your notebook. Then you're going to see if you can determine the function rule. What is the equation that matches that table? You see that you have 6 choices. Now notice that some of these are not quite as simple as the ones that we did together in our video. This one says x plus 7 is equal to y, so that's pretty easy. If you just add 7 to your x to get to your y, then that would be your function rule. But some of them are a little harder. Like this one says you have to multiply your x times 2, and we know according to the order of operations that that happens first, and then you add 3. This one says you multiply your x by 6, and then whatever you get, you subtract 4. So sometimes it's not just a clear add by 5 or multiply by 2. Sometimes it's a little bit more challenging. So be really careful as you pick through these examples today to see which ones you can match up. So what you'll do is you'll cut it out, you'll glue it into your notebook, you'll find the function that matches it, you'll cut it out, and you'll glue it with your table. And you're just going to glue 1, 2, 3, 4 into your notebook. Now you will have 2 extra functions left over. And that is the end of your notebook for today. Thanks, guys.